Hi, I'm Patrick Reagan. Welcome to the Network Routing and Routers, Part 8, Troubleshooting Routers and Routers. During this video, we'll discuss how to troubleshoot router and routers and cover common problems, including asymmetric routing. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. As discussed in earlier videos, when troubleshooting network problems, while your experience may have you check a couple of quick things immediately when dealing with the problems, you'll need to learn to use the troubleshooting methodology so that you can troubleshoot problems more efficiently and more thoroughly. CompTIA's troubleshooting methodology includes a 6-step process that allows you to frame the problem and guide you to identify and execute a solution. The steps include identify a problem, establish a theory of probable cause, test the theory to determine cause, plan, which includes establishing a plan of actions to resolve the problem and implement the plan or solution, verify full system functionality, and if applicable, implement preventable measures, and document findings, actions, and outcomes. Common router and routing problems can manifest as slow speeds, packet loss, or complete loss of network and/or internet connectivity. Troubleshooting routing and routers involve a systematic layered approach that moves from the physical layer up to the network layer, checking the hardware configuration and connectivity. The process varies from simple home networks versus complex enterprise environments, but the core methodology remains the same. For complex networking, nothing is going to beat experience. As I mentioned before, troubleshooting routers and routing problems requires a structured, top-down approach starting with the physical layer and moving up through the configuration and connectivity tests. Step 1, verify physical connectivity, which is layer 1. Step 2, confirm local connectivity and IP configuration, which is layer 2 and 3. Step 3, check routing tables and configuration, which is also layer 3. Step 4, test end-to-end connectivity, which is also layer 3. Step 5, review security policies. 6, analyze system health and logs. And 7, consult documentation and support. By systematically following these steps, you can isolate the problem area efficiently, determining the root cause and apply the correct fix. Verify physical connectivity. Check the basics. Ensure all cables are securely plugged in and the router is powered on. Inspect status lights by looking for green link lights on the relevant interfaces. Amber or red lights indicates a physical link or error state that needs immediate attention. For links that are not green, you may need to test the cables connected to the interfaces by using a cable tester and/or swapping the cable with a known good cable. Confirm local connectivity and IP configuration. Verify IP settings. Ensure your device has a valid IP address, subnet mask, and default gateway that match the network segment. Test local access. Try to access the router's management interface, usually via its IP address in a web browser or SSH. If this fails, the problem is likely localized to your device or the immediate connection to the router, not the wider network or internet. Access the router's command line interface and use a status command like show interfaces for Cisco and Juniper devices to digitally verify the administrative state and operational status of the interface. Check routing tables and configuration. Analyze the routing table. Log into the router and examine its routing table. This table tells the router where to send traffic for specific destinations. Look for expected routes. Verify that routes to necessary destination networks are present and active. Confirm the default route. Ensure there's a default route, which is usually 0.0.0.0/0, pointing towards your Internet Service Provider or ISP, or Core Network Gateway. Look for errors. Cyclic Redundancy Check, or CRC error detecting. When an Ethernet frame is sent, a frame check sequence to the Ethernet frame is added. When the Ethernet frame is received, the CRC is recalculated and compared to the original one that it was sent. Non-matching CRC calculation is an error which indicates that the frame is different compared to when it was sent. Runts are frames that are less than 64 bytes, which may be a result of a collision. Giants are frames that are 1,518 bytes or more, which is larger than the configured maximum frame size. Drops are frames not transmitted or received due to contention. Test end-to-end connectivity. Use ping and traceroute. Ping confirms basic reachability between the 2 points. Start by pinging known reliable addresses like the default gateway, then external services like Google's public DNS servers of 8.8.8.8. Traceroute shows the exact path traffic takes. This helps pinpoint exactly where traffic is failing or getting lost. Check firewall rules. Security policies, including firewalls, ACLs, and NAT rules, often inadvertently block legitimate traffic. Ensure that expected traffic types and ports are explicitly allowed. Analyze system health and logs. Monitor resource usage. Check CPU and memory usage to ensure the router isn't overloaded. Examine system logs. Log files can provide specific error messages and warnings related to interface flapping, routing protocol neighbors failing, or security policy violations. Consult documentation and support. Use vendor resources. Refer to the manufacturer's documentation for specific commands and common issues for your router model. Contact ISP support. If all signs point to an issue being outside your network, such as you can't ping past your ISP gateway, it's time to contact their technical support. Common router configuration errors range from basic addressing mistakes to critical security oversights. Being aware of these can prevent significant network disruptions. Leaving default credentials unchanged. The most common and serious security error is failing to change the default username and passwords for the router's administrative interface. These defaults are widely known to attackers and leave the network highly vulnerable to unauthorized access. Incorrect IP addressing and subnet mask. Misallocating IP addresses, leading to duplicate IP addresses, or using the wrong subnet mask can cause devices to be unable to communicate on the network. Forgetting to reserve static IP addresses for critical network equipment can also lead to conflicts when the Dynamic Host Configuration Protocol, or DHCP, assigns these addresses dynamically. DNS configuration errors. Entering incorrect domain name system server information can result in the inability to access websites and services even if there is a basic internet connection. Firewall misconfiguration. Overly permissive or improperly configured firewall rules can inadvertently block legitimate traffic or conversely leave the network exposed to external threats. Neglecting firmware updates. Outdated firmware can contain known security vulnerabilities and may be incompatible with newer devices or protocols, leading to performance and security issues. Improper Wi-Fi security settings. Using outdated or weak encryption protocols like WEP instead of the modern WPA2 or WPA3 leaves the wireless network vulnerable to eavesdropping and unauthorized access. Poor router placement. Placing the router in a corner, on the floor, or near major electronic appliances and metal objects can cause significant signal interference and limit the Wi-Fi signal's range and strength. Incorrect routing table entries. In complex networks, manual errors in configuring the routing table can cause data packets to be sent down inefficient or non-existent paths, leading to high latency or complete packet loss. Enabling unused services and ports. Leaving unnecessary services like telnet or remote access via HTTP or ports open provides potential entry points for the attackers. Disabling all features not required for operation enhances security. Troubleshooting route selection in the routing table involves systematically verifying that the router is aware of all necessary paths and choosing the correct one based on established rules. Remember, a route to the destination network does not exist, the packet will be dropped. An ICMP host unreachable message will be sent to the source address, and the source devices will be informed of the error. Check your routes in both directions. Adding a static default route can simplify your routing tables, such as creating a route to 0.0.0.0/0. Key steps for troubleshooting route selection in the routing table include: view the current routing table by using the appropriate command for your router's operating system to display the routing table contents, such as the show IP route for Cisco routers. Verify the destination's network presence by checking if a route to your target destination IP address is present in the table. If a route is missing, the router will simply drop the traffic, often sending an ICMP host unreachable message back to the source. Analyze route selection metrics. Routers use a hierarchy process to select the best path with multiple routes to the same destination exist. Specifically, longest prefix match. The router prefers the most specific route, the one with the longest subnet mask. For example, a route to 192.168.1.0/28 is chosen over a route to 192.168.1.0/24. Administrative distance, or AD. If routes have the same prefix length, the router uses the administrative distance to determine the trustworthiness. Lower AD values are preferred, such as directly connected routes have an AD of 0, and static routes typically have 1. OSPF typically has 110, and BGP typically has 200. You may need to adjust the AD if a less preferred route is being chosen. Metric. If both the prefix length and the administrative distance are the same, the router uses the router protocol specific metrics, cost, hop count, and so forth to select the paths with the lowest value. Confirm the next hop reachability. For the selected route, verify the next hop IP address is correct and reachable. The next hop is the IP address for the next router in the path. Use ping to ensure the next hop is alive and responding. Check the router's ARP table, show IP ARP on Cisco routers, to ensure it can resolve the layer 2 address of the next hop. Use traceroute to pinpoint failure. Review routing protocol status. Use a dynamic routing protocol such as OSPF or BGP. Ensure they are enabled and functioning correctly. Verify neighbor adjacencies are in an established or full state. Check for issues like route flapping or instability, which causes excessive updates and network disruption. Use commands like show IP OSPF database or show IP BGP neighbor to inspect detailed protocol information and ensure routes are being advertised correctly. Check for policy-based routing or filters. Sometimes an access control list or BGP configuration overrides the default routing table logic. Verify that policies are not inadvertently blocking or redirecting the traffic you are troubleshooting. Asymmetric routing is when a packet travels from a source to a destination using one path, but returns using a different path. Some of the problems caused by asymmetric routing can be dropped packets, firewall and session tracking problems, intrusion detection and prevention issues, performance degradation, load balancers and proxy may lose track of traffic sessions, performance issues, inconsistent policies like QoS and ACL policies, and monitoring and logging gaps. It can be especially problematic with stateful devices such as firewalls and load balancers that only see half of the conversation. This behavior can happen in complex networks where multiple routes exist between endpoints, such as in large enterprise networks or multi-home internet setups, whereas you're load balancing across these links. To solve asymmetric routing, you must first identify it, often by checking if the path in both directions differ. Then, you can resolve it by ensuring the traffic in both directions through a device, like a stateful firewall, takes the same path, often by adjusting default gateways, implementing policy-based routing, or ensuring symmetrical routing with specified cloud configurations like AWS Transit Gateways Appliance Mode. Configure routing protocols with metrics to favor symmetric routes. Use technologies like equal cost multipath or ECMP routing for load balancing while maintaining symmetry where needed. Implement redundant firewalls or load balancers that synchronize state tables. And use stateless devices and networks where asymmetry is unavoidable. Question. A network administrator is troubleshooting an issue with a new internet connection. The ISP is asking detailed questions about the configuration of the router that the network administrator is troubleshooting. Which of the following commands is the network administrator using? Choose two answers. Answers: show config and show route. Question. A network administrator has been assigned to a team that is currently troubleshooting a large-scale outage. The network administrator makes some configuration changes to an on-premise router to see if the link comes up. Which of the following troubleshooting stages is described in this scenario? Answer: tested theory to determine the cause. Question: network administrators troubleshooting a connectivity performance issue. As part of the troubleshooting process, the administrator performs a trace route from the client to the server and also from the server to the client. While comparing the outputs, the administrator notes they show different hops between the hosts. Which of the following best explains these findings? Answer: asymmetric routing. Question: clients have reported slowness between a branch and a hub location. You suspect asymmetric routing is causing the issue. Which of the following should you run on both the source and destination network devices to validate this theory? Answer: trace route. Question: you're investigating a performance issue on a dual link connection with VPN and MPLS to a partner network. The MPLS is the primary path, while the VPN is used as a backup. While communicating, the delay is measured at 18 milliseconds, which is higher than the 6 milliseconds expected when the MPLS link is operational, but is lower than the 30 millisecond expected for the VPN connection. Which of the following most likely point to the root cause of this issue? Answer: checking the routing tables on both sides to ensure there's no asymmetric routing. Question: due to concerns around single points of failure, the company decided to add an additional WAN to the network. The company added a second MPLS vendor to the current MPLS WAN and deployed an additional WAN router at each site. Both MPLS providers use OSPF on the WAN network, and EIGRP is run internally. The first site to go live with the new WAN is successful, but when the second site is activated, significant network issues occur. Which of the following is most likely cause for the WAN instability? Answer: asymmetrical routing. For more information, refer to these sites. In summary, troubleshooting routing and routers involve a systematic, layered approach that moves from the physical layer up to the network layer, checking hardware, configuration, and connectivity. Common router and routing problems can manifest as slow speeds, packet loss, or complete loss of internet connectivity. For enterprise networks, check interface status, review the routing table, verify routing protocols, and look for errors such as CRC, runts, giants, and drop packets. Asymmetric routing is when a packet travels from a source to a destination using one path, but returns using a different path. Thank you for watching this video. This completes the network routing and router series. The next series will be advanced network topics. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.